All right, everybody. Welcome to the video here for lesson number 6, the complex numbers. One of the things that happened in class, I did not get a chance to finish the notes here because my computer was going crazy. So we wound up doing them on the chalkboard. So I wanted to just do these last few notes questions with you. I know C and D, I had you just straight up type in your calculator. I'm going to show you through this video how to do them algebraically as well. If you want to watch this part, you can. If not, fast forward and you can get to the other part which goes over the homework. So let's just jump in here to number 4, multiplying complex numbers. So a couple things we need to know about complex numbers. Number 1, I is the square root of -1, therefore I two powers, like I squared, I to the third, I to the fourth, all have value that we can change them to. So we have to look for those when we're multiplying, especially because we'll get exponents. So for A, if I want to multiply this out, I'm going to make some boxes just to keep myself organized. You could do the distributing thing if you want. Another note, when you make your eyes, make them kind of like the fancy eye with the little tail on the end. If not, they kind of look like ones, right? So 5 times 2 is 10, so that goes in that top left box. 5 times -I is -5i. 4i times 2 is 8i. Remember, we're just treating I like a variable. And then the last box is -4i squared. So if I was to rewrite this, it would be 10 plus 3i minus 4i squared. But 4i squared can be changed. I squared is kind of like the sign changer. Whatever he's attached to is going to change the sign. So that's going to become 10 plus 3i plus 4. Notice I squared is really -1. So if we do -1 times -4, we get +4, which is why it's plus 4. Combine up your like terms, and I have 14 plus 3i. You can check this answer by typing it in your calculator. For part B, I see conjugates. So conjugates to me tells me to square the first term and square the second term and combine them with subtraction. If you don't see conjugates right away, or you want to just check to make sure that the middle terms cancel, make your boxes and go ahead and do it that way. It's going to be the same answer. 1 squared is 1 minus 4i squared. But remember, I squared is the sign changer, so that really just becomes 1 plus 4, which is just 5. Now notice it says a plus bi form, so I have to write this as 5 plus 0i. For part C, if I do 5 plus 3i squared, I got to use my boxes for that. 5 and 3i, 5 and 3i. So that's going to become 25, 15i, 15i. So then if I multiply 3i times 3i, I get 9i squared. So if I write this all out, I have 25 plus 30i, because 15i plus 15i is 30i, and then plus 9i squared. But I squared, remember, changes the sign of what it's attached to, so that becomes minus 9. Then I can combine my like terms, and I get my final answer of 16 plus 30i. Now, that is just what 5 plus 3i is. I now have to add that to 4 minus 2i. So I'm kind of bringing this down here. Combine up your like terms, so I have 20 plus 28i, which is what you got on your calculator. For part D, I have to distribute. So all those same properties work here. So I have 5 minus I minus 2i plus 6i squared. Combine up like terms, and remember I squared makes anything attached to it its opposite sign. So I have 5 minus 3i minus 6. Combine your like terms, -1 minus 3i should be your answer. All right, hopefully that helped you get through the last part of the homework that the smart board was not acting so smart this morning for. So Number one in the homework has us doing some evaluating of I. Now, if you have the newer calculator, you could just type those all in as is. If you have the older calculator, remember you have to use IPART. So if you go to IPART, since these are larger exponents, you can change I to the 13th to just I. You could do I to the 18th is -1. And you could do I to the 31st as -I. Plus n equals 0. I and negative I cancel. So now I have negative 1 plus n equals 0. Add 1 to both sides, and I get n equals 1. Number 2 says express the following quantities as a plus bi form. So if we multiply these out or add these up, we can do that. So 1 plus 1 is 2. I plus negative I is 0i, so 2 plus 0i. If you don't have 0i on your paper, that would be wrong. It says a plus bi form. Multiplying, those are conjugates, so I'm going to do 1 squared minus I squared. So I have 1 minus I squared. But I squared is really going to be positive 1 here because it's a negative, and then I squared is negative 1. A negative and a negative makes a positive 1. So I have 1 plus 1, which is just 2 plus 0i. For the next one, we have to do some box work here so we can make our multiplication box. So I have 1, negative 1, 2, negative 3. So I have 2, negative 3i. So that would be negative 3i, negative 2i, and positive 3i squared. I'm going to wind up getting then 2 minus 5i. 3i squared is going to change to a minus 3. If I do some distributing here, I get plus 3i minus 3i squared. But 3i squared is going to become plus 3. So I have 2 minus 5i minus 3 plus 3i plus 3, because remember, I squared changes the sign of whatever it's attached to. Clean this all up by combining like terms. 2, negative 3, and positive 3 is just 2. Negative 5i and positive 3i is minus 2i. You can type that in the calculator too to check it. 3i squared, so if I do 3i, 3 plus I, 3 plus I get 9, 3i, and I squared. So that's going to wind up giving me 9 plus 6i plus I squared minus 18 minus I. I squared, remember, is negative 1, so it becomes 9 plus 6i minus 1 minus 18 minus I. Combined up all your like terms, so I have 9, negative 1, and negative 18, so that becomes negative 10. 6 and negative 1 makes positive 5i. Number 3, finding the solutions to this in a plus bi form. This is always on the Regents exam, using the quadratic formula and getting a complex solution. So we are going to plug into the quadratic formula. So we have x equals the opposite of b, so positive 4 plus or minus negative 4 squared, which we know is 16, 4 times 1 times 13, all divided by 2 times 1, which is just 2. So now we have x equals 4 plus or minus the square root of some number, all divided by 2. So if I typed all that in the calculator, everything that's underneath the radical in the discriminant, we wind up getting negative 36. Then, because we know that's going to be a complex solution, we're going to separate this up because complex solutions always need to have a real part, 4 over 2 is real, and an imaginary part, 6i over 2. Where did 6i come from? The square root of 36 is 6, so the square root of negative 36 is 6i. Simplify, 4 divided by 2 is 2, 6 divided by 2 is 3, so 2 plus or minus 3i. Remember, complex solutions always have a buddy. They're always in pairs. So here we have a positive and a negative solution. That's it. There's your video. Hopefully that helped clear up the questions you might have had at the end of the period, and also hopefully that helped you with your homework. Good luck with everything. See you tomorrow.